Welcome back to Chapter 11 videos. We're in our first video after the mid-chapter checkpoint quiz for Chapter 11, and it's actually 11.6. We're skipping 11.5 for now. To me, the book doesn't really make sense in the order that they set this up, so I will come back to some example problems from 11.5 later, but we're going to go straight on to 11.6 for now. Although the one thing I do want to point out at the start of 11.5 is just a definition for volume. So if you look really briefly at page 623, which was 11.5, volume is the measure of the number of unit cubes, or cubic units, needed to occupy a given space without gaps or overlaps. All right, and so really what would happen is, I want to go back to 11.6 first, get myself there, and then I'll show you some pictures. So if I have this is actually a cube, okay, so it's all square sides. It has this hole here. If I were to fill, so if I took water and poured it in there, however much water it could hold, that's capacity, that is volume, all right? And volume is really simple for rectangular prisms or cubes. You're multiplying your three dimensions. So in this case, like length times height and width or depth, all right? Here on this one, I would have my three dimensions of across here, and then up, all right? So it doesn't matter which one you want to call length, width, height, they're really interchangeable. But that's what you'll find right here on page 629. You will find right here are, actually it's right at the top. So you can use the formula volume equals length times width times height. It's right there. I'm just making it larger to find the volume, which is capacity. All right, how much something holds, all right? So it's not area. Area was just two-dimensional. This is 3D, three-dimensional. We call volume, okay? So pretty simple. They're going to talk about, it's an obento. An obento is a single portion meal that's common in Japan. It's usually served in a box, and this box is a rectangular prism. And you can see here they're telling us that it is 5 inches long, 4 inches wide, and 2.5 inches high. How much food fits in the box? Really, they're asking us to find the volume of the box, okay? So I need to know, I'm going to actually tilt my whole thing here a second and tilt this with it, get myself set here. And so we have 5 inches long, 4 inches wide, 2.5 inches high. I always start with my formula. So volume equals length times width times height. They just want us here to fill in what we know. Length was 5, width was 4 inches, and height is 2. Instead of 2.5, I'm going to use 2.5 because decimals are easy to put in a calculator. And yes, you can use a calculator for this. So we just fill in down here. So they rewrote the formula here. Length was 5 inches, width was 4 inches, and height is 2.5 inches. And if I take my calculator, you might not even have to, but 5 times 4 is 20. And so if I took 20 times 2.5, I'm going to get 50. Or if you did that with mental math, 20 times the 2 is the 40, and then half of 20 is another 10. You get 50. And now it's cubic inches. I'm going to write this really big. So 50, and it's inches to the third power. And we say that as cubic inches. Okay, why is that? Because I have 1, 2, 3 different dimensions I'm multiplying together. So inch times inch times inch is inches to the third power. Cubic means the exponent of 3. So our box contains 50 cubic inches worth of space or food would fit in there. I'm going to skip over 630 for right now, so I want you to go one more page past that. So 631, so 2 pages past where we were. I want to do one more example. So if I have this rectangular prism up here, 10.5 inches dimension, 15 inches, 25 inches. Again, doesn't matter which one you call which, but let's call this length, we'll call this width, and we'll call this one height. There's not a lot of space there, I put them above. Write your formula, V equals L times W times H, substitute in V equals, and my length was, I'm going to use decimals, 10.5, my width was 15, and my height was 25 inches. If I take my calculator, 10.5 times 15 times 25 gives me, ooh, that seems really strange. It probably is though, 3,000 something. Let me check it again. 10.5 times 15 times 25 probably is, yep. So 3,937 and 5/10 cubic inches. Cubic inches. Again, inch to the third power is how I show that. All right. So one way of finding volume, capacity, how much something holds. Formula for rectangular prism, volume equals length times width times height. Now I'm going to come back to 630, and they show you the volume in a different way, different formula. And I kind of like it. I know in the past the kids really did actually make sense of this. So we know that volume of a rectangular prism is a product of length, width, and height. Since the product, which means multiply, of length and width is the area of a base, I can take the area of the base and multiply it by the height, and that's going to give me the same thing. So what they're doing here is they're giving us the formula of V, volume, equals big B, meaning area of the base. That's what big B means, area of the base, times the height. So what I'm talking about, let me show you with this example here. So if I have my rectangular prism, right, and here's my base, right? So if I find the area of this base, right, that's that short piece. Now, that's down here. If I then take this area and multiply it by this height, pretend that I'm pushing this all the way up through, all right? So I'm taking this area and when I push it up, let's pretend it's filling, right? So if I took this area and filled along that height, the whole thing would be filled, all right? So another way of thinking of volume, take your base, area of your base, and then multiply it by the third dimension or the height to pretend you're filling it, right? And that's what they're doing here. So they have here, we have the area of this base is 9 square inches. And besides the fact that they have it grayed in, the thing that really tells me that that's an area is that it's inches squared, all right? That's an area. Then if we take that and we multiply it by this height, so I'm taking this rectangle and pretend I'm filling it all the way up along this distance. That's what's going on there. So V equals big B is area of the base times the height. All right, so you got to be sure that your height is the one that's, again, perpendicular 90 degrees to the base that they give you. Because sometimes they're going to do things like turn it on its side, give you the side, and you have to realize that we're multiplying across the distance here. It's not always going to be up and down. All right. So the height is 2 1/4, which is, I'm going to put 2.25 because, again, easier for your calculator. 2.25, 0.25 is 1/4. The area of the base is 9 square inches. So write our formula, V equals big B times H. Big B is my 9 square inches, height is my 2.25. So 9 times, now they went right to improper fractions. So I guess for right now, let's keep that as the 2 1/4. And 2 1/4, 4 times 2 is 8 plus 1, so 9/4 is my improper fraction. So that's what they're doing here. So 9 times 9/4, remember this would be 9 over 1. So I get 9 times 9 is 81 over 4. And 4 would go into 80 20 times. And I would have 1/4 left over. Again, if you do want to do, let's do it with a calculator. It's just easier. V equals 9 times 2.25. Volume equals, and let's pull out the calculator and give that a try. So 9 times 2.25 is 20.25, or 20, it's 1/4. And that's what the same as here. And inches to the 3rd power, cubic inches, is my volume. So that's, I'm going to use the decimal version over here. Inches cubed. All right. All right, and then they show you one more example down here of the volume of a cube. And remember how with a square for area, they used S for side length. Well, they're doing the same thing here now. So instead of length, width, or height, they're all the same, right? So if this is 3.5, 3.5, 3.5, and instead of using L, W, or H, they use S for side length. So the volume of cube, you can use the formula V equals S to the 3rd power. Again, if you still want to use length times width times height and just multiply the 3 of them together, that is totally fine. Let's see, they are going straight to improper fractions here. So 2 times 3 is 6 plus 1 is 7 over 2. So 7 over 2 to the 3rd power is 7 over 2, 7 over 2, 7 over 2. Again, if you wanted to leave it as, I'm going to put it down here, I think, volume equals, we could go 3.5 times 3.5 times 3.5. I much prefer that actually, because I have a calculator here that doesn't have fractions, and you know I don't like to put fractions in calculators. So 3.5 times 3.5 times 3.5 equals, and I get 42.875. And because I had, let's see, 7 times 7 times 7 would be, it's going to give you the notes here, 343 over 8. And that is my 42, and 42 times 8 equals 336. So that's, they're getting 7 left over. So if you took the fish off the dish, you did the whole division, you get 42 and 7/8. 7/8 is the same as 0.875. Again, for simplifying life, I prefer to deal in decimals. And we can't forget our units though. It was feet, and it's feet times feet times feet, which is cubic. All right, so there was our last example, just changing over to S's side length for a cube, just like a square. All right, I was a little mixed up and thought the example I wanted was back there on 631, but it's actually over here on page 633. So I would need to do number 7 with you. That's one, so we're going to kind of back out a dimension when they give us volume, kind of like when we had area of a parallelogram and you had to find the base or the height when they gave you the area. It's kind of similar. So a cereal box is a rectangular prism that is 8 inches long and 2.5 inches wide. Okay, so 8 inches long, 2.5 wide. The volume is 200 cubic inches. What is the height? So remember, volume equals length times width times height. Okay. Now, just like back with that parallelogram, I know this on the left-hand side of my equal sign. The volume is 200, so I'm going to substitute in here 200 equals. Okay. Length was 8 inches times width is 2.5. And I don't know the H. That's what I'm trying to find, so he stays as H. This should all look kind of familiar. All right, we did this before. Now, I'm going to rewrite. I have to come up here. So 200 stays on the left of the equal sign. 8 times 2.5 is going to be 16, plus another half is going to be 20. So 20 times H. All right, if I just went too fast for you on that, again, take this on your calculator. So 8 times 2.5 is 20. I knew that because 8 times 2 is 16, and then half of 8 is another 4, and that's 16 and 4 made 20. Times h, because I don't know h. Remember what we need to do. Isolate this variable. I got to get h. I want h equals. I got to get him by himself. So I need to use that inverse operation thing like we did back with area of a parallelogram. So h is being multiplied by 20. I need to do the opposite. I need to divide by 20. Whatever I do on one side of my equation, I have to do on the other. I am using fraction bars to show divide. 20 over 20 is 1. So 1 times h leaves me with just the h equals. And if you put in your calculator 200 divided by 20, I'm going to get 10, and my dimensions were inches. So my height is 10 inches. So I use that inverse operation technique to get h by himself. 200 divided by 20. I keep saying that backwards, sorry. 20 divided by 200. All right, so what I would like you to do was page 631, and then for whatever you see much time you have between this and next class, 633 to work on these volume problems. So as many of these as you can do. Certainly you could try, should get a mix of ones where they're giving you big B versus length times width times height, couple word problems, because it's always important to apply them to the word problems. And we'll see you next time.